Hello, everyone. I hope you're all doing well. Did any of you already start reading the slides and going through the videos? So thumbs up if you've gone through the slides. Okay, everyone.
Ben, just tell me which slides are these? Are we going
The first one, Introduction to Blockchain.
Muqtada, is this something that you sent via
Yeah.
WhatsApp or something?
Yeah, I shared it to you via WhatsApp as well. It was in the GitHub repository.
Oh, that link. Okay, I saw
Yeah.
you sent it this afternoon. Okay, sweet.
Okay, so based on that, does anybody have any question? Tonight I'm going to give you a visual of how blockchain works. So let me share my screen. Okay, this let's show you a visual of how blockchain works. So this is the slide that I'm talking about. Introduction to blockchain. So here you're just going to see a bit of a history of how blockchain started, how it was created, and also how it works. Here it talks about the block structure, the header, transactions, and all that. So it gives you an overview of how blockchain works, the benefits of blockchain, and it's not too much information. And but today I just want to show you how it works, just to give you more understanding on how blockchain works. So if you've read through the slide, you already went through hash. Should have learned about what a hash is, what blocks are, and blockchain. But now here I'm just going to show you how it all works in a visual. I'll show you a visual of how it works. So here you can see there's an hash here, down here, and here there's data, and the data is empty. So there's nothing that is on the data, but it has an hash of a fixed length. So let me type some stuff here. Let me type my name. You see the hash changed. So I can like type Ben, and you see it starts with 030 and it ends with F4. Let me make a simple change. Like, let me just type a full stop, and you see that the hash totally changed. So with the SHA-256 hash, it's one way. So you cannot derive a data from the hash itself. But whenever I type Ben, I'm going to get the same hash. Like if I type Ben, you're gonna see the hash of Ben 030, and it's the same thing, doesn't change. But I cannot use the hash to derive this data. There's no way of doing that. So this is the first step, understanding of what the hash is. Now let's move forward further. And here now we're going to understand what is a block. So here there's just one major difference. Instead of one big block of data, now it's split into three. We have data, we have nonce, and then we have block. So all these information that you get from these three fields creates the hash. So here there's a 1, the block number 1. A nonce, we get into that. There's also a nonce here, 72608, and then there's an empty field of data. So all these three information from the field create this hash. And you can see that the hash starts with 40, which is kind of odd, but you'll understand why it's like that. If I type 1, you see now my hash has completely changed. I can type my name. So it takes 1, it takes the nonce, and then it takes Ben, and it creates a new hash. So now what we have here is we have a block with data and a nonce, and it gives me a hash. So now here is what is so important. You see here, there's mine here. So if I click mine, something is going to happen. So this is basically how blockchain mining works. So when I click mine, what's actually going to happen is this nonce, this machine is going to be looking for a nonce, like from 1, 2, 3, 4. So it's going to look for a nonce in such a way that if that nonce is found, combined with the data and the block, it must output a hash that starts with 40. So basically it goes like 1, 2, 3, 4, 5. And you can see as I'm typing 5, 6, 7, 8, the hash is changing. So it does that until it finds a nonce that, so in such a way that if the nonce plus the block plus the data, the resulting hash must start with 40. And that's how Bitcoin works. Bitcoin solves a mathematical problem. So the first computer to solve that problem is the computer, the machine that's going to mine, and will then get a block reward. So click mine. So it's just gonna look through nonce 1, 2, 3, 4, 5, 6, 7, 8, and to go on and on and on and on until it's going to find a specific nonce. So you see, it's the same nonce that you saw. Because I didn't change my data here, so it's still 72782. So whenever I put all these three information, it's still going to result the same hash. Okay, I'm gonna pause a little bit, just to see if there's anybody who's confused. Anybody's confused so far? Yes, Miles?
Hey, yeah, not confused. Just want to add a little bit of something maybe. Yeah, those 4 zeros in front of the hash won't always be 4 zeros. That's known as the block difficulty. So as mining more Bitcoins mined, the block difficulty increases. So then your hash has to have 4 zeros and 5 zeros and 6 zeros, and that's where the computational power comes from.
Yeah. Thank you, Mark. Thank you for adding more information. I really appreciate it.
Yeah,
so everybody understand what a block is so far. So when we talking about a block in a real blockchain sense, let's say in Bitcoin, for example, the data can be transactions like Ben sends $50 to James, something like that. And it's gonna be like, sorry, it's gonna be a list of transactions. Like I send person A. So nonce are just the hash while keeping the same data.
Yeah,
So-
you could think of that. You wouldn't change the data in the block, would you? That's not ethical.
No. So a nonce does not have, so it's not there to, so yeah, the nonce is going to adjust the hash, but the software, we, like Marv mentioned, is block difficulty. Here the block difficulty is the hash only has to start with 4 zeros. So that's the block difficulty. So so now the software that we have that is running the blockchain, we look for a nonce that once it's combined with the data and the block number, it should result in a hash that starts with 4 zeros. So whenever I change, I don't have to, so if I change data here, for example, you'll see the hash change completely. Even if I change the block number, the hash change completely. Same with the nonce. I can change the nonce number and the hash change completely. So we're just trying to figure out which nonce combined with this information will result in a hash that starts with 4 0. Yeah, so now let's move to blockchain. So now we understand what is a block. Now we're going to a level further. So now here you see there's a chain of blocks. And something you're going to notice here is the first block has, here this previous and then there's a hash. So now we have an extra field, block to block, nonce data, and then previous hash. But if you look at the first block, the previous hash is 0, 0, 0, 0, 0, 0, 0. And so this is just they call it the genesis block. But if you look at the next block, you see the previous hash is this block's hash, and then so on and so forth. So you see previous hash, and then there's a hash here, 0012, 0012, and continues like that. So now I'm gonna ask a question to you guys. Why do you think it is so? Why is there previous hash in all these blocks? What's the previous? Why does this block have a previous flash of? Yes, Jocks?
I think the most basic, straightforward answer here is so that you can have full transparency of the chain, because obviously there will be multiple chains, and it's about which one is the next in line, right?
Yeah, and also another thing also is the security. To ensure that no chain is changed, no blocks is changed, because once you change something, then okay, what do you think will happen if I go to this block? Let's say I'm going to block 3, and then I type in data. What's going to happen?
We're gonna print money, bro.
So if I type some stuff here, you see the whole chain is broken. The whole chain is broken. Now the whole chain does not make sense anymore, because now that I've typed some data, then you see that my hash has changed. My previous hash is still the same, because yeah, this was a valid block, and all the blocks that follow have now are just broken. I can even if I mine here, let me mine, then you'll see. But here we're talking about one computer, so one node with one chain. if I mine, then you find that if there was any blocks, let's say if this, let's say we have a whole block, we have like different blocks, chain that way mined, and then someone tries to hack, for example, try to change data from the third block. So I'll be able to change it, but then it's going to mess up all the blocks that follow.
So in that case, you would mine that block on your node, and the rest of the nodes in the system would mine the original data. So then they would kick you out or kick
Yeah.
the block out for not reaching consensus. Everyone wouldn't agree.
Yeah, because it has to agree
then-
with the remaining nodes.
Mm.
Yes, Ethan?
Hey, just trying to understand what made the block red.
It's red because it's not mined. It's not
Not-
valid. If it's mined, it has to have the hash. According to block difficulty, it should start with 40 for this block difficulty. So if it's not the case, then it's red.
So in this context, in this
In this
scenario, what is mining? I'm saying with air quotes.
Hey, Mukta, you wanna add something?
Yeah, so I'll start off with what is mining. So mining, basically you have a block. You have a bunch of transactions that need to be computed and placed on the network. So there's a mining machine, whether that's software or whether that's hardware. Something needs to validate these transactions. It validates the transactions, and then it says, okay, this is a good block. If it's a good block, it'll basically be the transactions are recognized, and then the previous hash will be validated in that block. But there's a whole bunch of ways that blocks can essentially break. If, let's say, what we have here now is on the red green side, you basically have where the blockchain agrees something happens. On the red side, it's basically where certain miners don't agree that something took place. But if, let's say, the coin had to fork, or, okay, I'm going to get technical now here. But essentially, if certain miners have to agree that something is valid, then it's a valid block. If they had to fork and you have one group that basically says that this is a valid block and they want to reject a block that even like other miners want to say that it's valid and it's not, they can, and you can actually have a split in the blockchain in that sort of sense. Does that make a little bit more sense to you, or did I just confuse you?
I think it makes a bit more sense. But does that mean we're saying that there's many different computers mining at the same time in this example?
Okay, so in this example, let's just say it's one miner, but
So
in
this is-
general, there are lots of different miners. And then each of those miners, basically, what will happen is miners will come to a consensus. Someone will say, I have won this block. I have the computational answer for this question. They put the next block in. Then what happens is, when the next block is being processed, because after 10 minutes, in Bitcoin's case, one block will come out. Then they'll basically say, so you had the old block, you had the new block. Then you're going to have a new block. Is the old block, is the new block basically going to be written over by the new block? And that's basically how so you have like one, and this one is valid. Everyone agrees this one is valid. Then you have this one coming along. People say, then they have to validate it for the next miner as well. For the next mining round, essentially. For the next block. Sorry, guys, blockchain. For the next block. And then they basically say, okay, we agree that this is the case. So it's similar to basically typing into your calculator, what's 5 plus 6? And if the computers agree that 5 plus 6 is the next one, then it prints the next block. But then they all need to have consensus, because at any moment in time, one group of miners can say, no, we have a different answer. and you could have party A and party B saying, no, we have the right answer. And multiple blocks can go forward as potentially being the right answer. But eventually, enough of them will reject the wrong block and go forward in a different direction. Or you will have a fork in the blockchain, and then you will have party A, group A going this way and group B going that way. But hopefully that makes sense. Sorry if it didn't.
So just to regurgitate that in my own words, it's solve for X and everyone's got to agree on what X is.
Yeah, that's 100% correct.
Okay, so
And if it-
what would
Jacques,
X be in
you-
this block, seeing that it's green? I mean, seeing that it's red, how would we make it green? Sorry.
Jacques, want to say something? So here, okay, just to answer that question, what is the X, right? What is the X? Is that the question?
Yes,
Trying to
in this
solve
red
X.
block.
Yeah. So the X is the nonce in this case.
Mhm.
So you're trying to get a nonce in such a way that if the nonce plus the block plus when you put the nonce plus the block plus the previous hash, it should give you an hash that starts with 40.
Okay,
Yeah. So the
so the
so the
nonce
com-
has to make the hash start with 4 zeros, and that's what makes it correct.
yeah.
Okay.
So computers basically compete to be the first node to find the correct nonce. That was
And then also, Ethan, also I think what maybe is confusing you is the reason the block number 4 is red is because he went back, Ben went back and changed block number 3, so the hashes don't match. The previous hash of block number 4 doesn't match the hash of block number 3, so there's a break, and then consensus wouldn't happen. Like the hashes wouldn't match up, and yeah, that's the break in the chain that you're seeing.
yes, Ethan.
Okay, so solve for X, make sure that the hash starts with 4 zeros, and that's what makes it green. Now, and everyone agrees on what X is. Is there multiple solutions? Is there multiple values that can make the hash start with 4 zeros?
No.
Is there only one
No.
possible nonce?
That's like the first nonce that can get that, because it looks from a number like from 1 going up to infinity.
Oh, until infinity. So there's multiple answers that could
So then-
satisfy.
So there can be a different nonce that can have a different hash. I mean,
Okay.
a different nonce that can have a different hash pattern. And a
Okay.
hash that also starts with 40. But this is the first number that is found.
I see. Okay, last follow-up question then. If there's multiple solutions that can validate the hash, then what if somebody changes the nonce of a previous block to a different nonce that still makes the hash start with 4 zeros?
So we can actually do that.
Would
so
that
we-
invalidate the whole chain, or is that still a valid chain?
I don't think that's possible. Once a block has been hashed, you
No.
can't go change it.
Yeah,
Let's say-
no,
let's say
Blocks
you
on
have a mo-
blocks.
So let's say
Sorry,
that
I'm gonna let
first of all, Yeah?
Jacques was saying something first, and then Miles, and then me, and then Ben. Yeah.
Sorry. So Jacques, were you done? Sorry.
Oh, sorry. Do you want me to repeat what I was saying?
yeah.
Oh, I was saying once the block has been hashed, as in the calculation has been complete, you can't go back and edit it. That's the whole point of the blockchain. So no one could go back to the previous block and edit that. If it does, then the
Yeah, that's
nodes
right.
aren't going to confirm with each other. So
Mhm.
consensus won't be reached, as Miles said earlier.
Yeah. But I think also
Yes,
in that case, what Ethan might be saying is two computers have different nonces, and that compute a hash that starts with 4 zeros, but the hashes are different. Whoever gets there first is the winner. So if you find a nonce 1 that does it, and somebody else finds a nonce 3 that does it, whoever proposes it first is the winner. I think That's how it works.
So,
That is correct.
but you guys are both right, but it doesn't, essentially it's an agreement. So there's what he said, she said, and the truth. And essentially in blockchain, it's basically whatever the truth is, not necessarily the truth. But if you have more hashing power and you basically can determine what blocks are supposed to go forward, technically you can break it. So this is just like an outlier case, but it doesn't have to be whichever writes further ahead. We've had multiple instances on multiple chains where they've decided to undo history. And whether that be for whatever reason they want to undo history, they've undone history. Where they basically say, okay, we're going to scrap all of these blocks, we're going to go back to this point, and then we're going to continue forward. But it can also be from a mining attack perspective, where you could have essentially a group of miners that go in one direction, and they say this is the answer that we want to support, and you have another group of miners that say this is the answer we want to support, and essentially it can go in two directions. It doesn't have to go in one. Generally, the economic incentive turn to the thingy you're also, you're not going to get paid. So there are a lot of them to cover that. And if you guys do really want to chat about that more, you can just
I
raise
don't know
some
if it's me,
questions.
but we're losing
You
you.
can ask them.
We missed like half of that last sentence, Mukhtar.
Okay, sorry guys. But essentially how it works is, yeah, it's fine guys. Like I think basically you can go in either direction. Basically consensus means that whoever has the majority rules the direction that the chain goes. So if you have more
Oof,
miners
losing you.
in one direction, it goes
Hey, Mukhtar.
that
Mukhtar.
Ish.
stress guys.
Mukhtar. Mukhtar.
He's
Can you
turning
hear
into
us?
a robot.
Oh, it's-
But I think I got the gist of what Mukta was saying. What I
Basically,
would
sorry, Ethan. Basically, what he was saying is 51% of the miners have to agree on a block for it to
Yeah.
move forward,
51%.
to be appended to the chain.
Yeah.
Yeah. So if you have a network that has 4 nodes, and you know 3 of the people that run nodes, you guys can collude to move the block in any way you see fit. Whereas if you have 100 or 1,000 or 1,000,000 nodes, it's harder to pull off that 51% attack.
So, okay, what I expected the answer to be was what Jacques mentioned, which is that once a block is defined on and found consensus, it's unchangeable, right? So
Yes.
it makes sense. And your answer, Miles, also made sense to me because it's whichever one comes first solidifies that in stone, right? What confused me about this example is that Ben was able to, scroll horizontally and change past values. That's kind of what confused me. But in real life, that wouldn't be able to happen because once the blocks are mined and agreed upon, they won't be changeable. Is that right?
Yeah. So in real life, someone can try to change, but that change will only happen in that person's node, in that person's computer, because you have to also have consensus. I can try to cheat the system, but are other nodes gonna agree with me? So that's it.
Yeah,
That's
that's
the
the
power
power of
consensus.
consensus.
Yeah.
Yes. And so to change a blockchain, to change history, that would require a coordinated strike and trust, wouldn't it?
Yeah.
You
Just
would
like
basically need everyone to agree on their change before it even goes live.
Yeah, which surprises me that it actually happened already. that fact was weird.
Just like here, for example, we have A, B, C. So we have three nodes,
Ah, okay.
right? We have
I see.
here A, here B, here C. And
So
if you check, yes,
theoretically, there are multiple solutions. So one nonce and another nonce can result in 2 valid hashes, right? But
Yeah.
if 2 out of 3 peers remember that nonce A was the nonce that solved the hash, then peer C can say whatever it wants, even if it's right, it's disagreed with. There's no consensus.
How far is the zero?
so let me just give you, yeah, sorry.
Yeah, I think you're right. That you're on the right track there, Ethan. So two out of the 3 nodes would then could then say no, we disagree with the one outstanding node, and we propose that this is the block. They could
Yes.
totally do that.
But if
Yep.
all 3 peers change the nonce to a different correct nonce,
So when can
then the
be
Oh, yeah, then-
one would be valid.
Yes.
Okay.
Then when can
Just
be
like
valid?
here, you see the 3 different nodes, they all have the same chain, like the same values, the same chain. So if I change something here, I can mine it to something valid. Let me start here. Okay. So I move on. Valid as well. And just one here.
Sorry, Ben, your mic's a bit soft there, bro.
Let me try. Just hold on. Let me add my mic. I don't know. Maybe.
We can hear you now again.
You hear me? Is it better?
Yes.
All right. So, okay. So here I'm just changing all the data here. They're all different. Oh, let me just stop here. Let me pause here, or else it's going to be so slow. Okay, so this looks valid because the hash is valid, but I just put some wrong data here. So this is where consensus comes in. If 2 peers, so now there's peer A change some information, change the data, and then peer. So the other peers, what they do is they're not even going to have to look at the data. It's not even looking at the data. It will just look at the hash. So if the hash from here does not correspond, if the hash from the 51% at least does not correspond with this, and this one is going to be kicked out. So we have false data. Let's look at it. Let's look at this hash here. The third let's go to block number 5. The hash is 00E2. And let's go to 5 here. Yes, hash. So most nodes will be like, no, but you don't correspond with our hash.
Yeah. Ben,
Yeah,
can you hear? I don't know if anyone is having to anyone else, but your mic keeps fading in and out, eh?
Sorry.
Can you hear me?
Yeah, to be honest, I probably missed like the last 2-3 minutes of what you just said.
Okay, so I was saying that I made some changes. So this is one node that's trying to be malicious. Node 1 want to be malicious, want to change data. So I changed the data and I mined, and I also mined the subsequent blocks. So everything here looks valid, it appears valid, right? But when I look at my other peers, the majority of the peers don't agree with what is here. And it does not even have to. So the other nodes don't even have to look at my data. They only look at the resulting hash. If a resulting hash of a node does not correspond to the majority of other nodes, then this node will be kicked out, won't be trusted. Does not correspond. Does it make sense?
Makes sense.
And here now we're going to see it in action. Yes.
So let's say a node doesn't match up. Does the machine or hardware or software that tried creating that incorrect node, does it get flagged as a bad actor? Or is it allowed to continue processing more blocks?
Okay, so in Stellar, what happens with Stellar is that block, that node just going to be ignored. Because with the way the consensus mechanism works with Stellar, it works kind of like in groups of quorums. So there's a group of quorum, and they call it the trust quorum. And anybody, so once you have your node in a system, you are free to select which node to trust from your to be part of your quorum set. Let's say one quorum will involve Eldon, Ethan, Costa, and Donald. So there's 4 of you. Now let's just say 5 and Gareth. So there's Eldon, Donald, Costa, Ethan, and Gareth. So that is your quorum. And you, Ethan, you trust Costa, you trust Donald, you trust Adrian, you trust Gareth. And if now, for example, if there's a transaction that has been sent, and Costa, and it's broadcasted over the network, and Costa, so that determine that transaction was valid, Ethan and Donald as well, Alden as well. So 3 people in your quorum set agree on something, a statement is valid. Then you also going to agree. You don't even have to wait for Gareth to agree, because as long as 3 out of 2 people agree, then automatically the whole quorum is going to agree. But then imagine now there's a lot of groups like yours. There's like thousands of groups of 5 quorum. So Ethan, in your group, you've come to an agreement, and then there's another group of 5, they've come to an agreement, and another group, you don't know each other, maybe in China. One of the nodes is in China, the other node is in Europe, but 5 of those nodes agree, and then other 5 also agree. Then consensus is going to be reached quickly, because there's no ways that we can lie, we can have false data at the same time. I don't know if it makes sense. So that's how it works with Stellar. So if one node is not telling the truth, then the way Stellar works, it's just going to ignore it, because it's not going to be trusted anymore. If you that machine continuously gives you false data, then it's not going to be part of the trusted node in the quorum. That's how it works with Stellar.
Okay, that makes sense. Cool.
So this is how it works in action. A block has all these transactions, like $25 from Darcy to Bingley, $4 from Elizabeth to Jane. So all these transactions, plus the nonce, plus the block, plus the previous hash, all of them together they create an hash. And it goes on. PRB has the same data, and yeah, everything is valid. So that's how blockchain looks like in action. So now we're going to move on to so far everyone understand? Does anybody have a question? Jacques?
Sorry, man. I don't know if this has been answered, but you said the 4 zeros is the difficulty of the block, right?
Yes. So this is not Stellar. Here I'm not talking about Stellar. So this is just for you to understand how blockchain works. It's not Stellar specific. And it's just an example. Yeah, here the 4 zero is the block difficulty in this case.
Okay,
of the
and
proof of work.
that can change at any time. And how do we know? Does more zeros equal more difficulty, or does less zeros equal more difficulty?
So in this case, so the block difficulties is basically how hard is it for you to get that specific hash. So to get a hash that starts with, let's say 50, it's going to be difficult because if you go back to let's go back to a hash itself. Like I can put any data and you see any small changes, the hash change differently. Any small changes, I can change the J into K, for example. It's a totally different change. I can change it to a K, so it's totally different. Now imagine now we're trying to look for an hash that starts with 40, not just 10. It has to start with 40. So how many changes do we have to make? Like we have to look through, like I think here is gonna show a better way, like here in the block. So it has to loop through, because if you want to find 40, then we're gonna have to loop through like 1, 2, 3, 4, 5, 6, 7, 8 up to infinity. So now if you're saying it has to start with 50, because here it's 4 zeros, let's say 50, it's going to be even more difficult.
Okay, cool. That answers my question. So depending on how big the data set gets would determine how many, let's say, zeros the hash would start with for that block.
Yeah, and also as like in the case of Bitcoin, as more nodes are joining more miners are joining the network, and so it becomes much more harder. The block difficulty becomes even much more harder. Because if it was easy, then how are they going to compete at the first place? Mukhtar?
Okay, I'm gonna try talk. Can you guys hear me?
Yeah, we can hear you, bro.
Okay, cool. So basically, if you think about hashes, a hash is basically a solution set. So the more zeros there are, the less combinations that there are that can be the answer. Because your number is smaller. The smaller your number is, the less chance that you're going to have more nonces. The bigger your number, the more nonces are possible to be the key that unlocks the block. So essentially, the more zeros basically just make it harder to find a nonce, because now instead of having a bigger data set, you have a smaller data set of keys that actually unlock it. I hope that makes sense.
Perfectly, yeah. You said it
Yes,
perfectly.
it does.
Thank you, Mukhtar. And let me quickly go to, maybe this for your own homework. Homework for you is to go to Stellar Expert. Let me share with you. So Stellar Expert is the Chain Explorer of Stellar. Like we say, blockchain is transparent. Anybody can see. You can see all transactions, all the history of the Stellar transaction. Like here, for example, we can see how many trades happened within the past 24 hours. Like XLM circulation. You see the total account. So total account 10 million. You can see. So this is the past 24 hours. Hello? Yes, Miles?
Can you see specific transaction details?
Yes, let's actually look at one transaction. Yes, but you're not gonna know who sent the transaction, but you're just going to see the address.
Yeah, I
we
understand
can.
that. I
Let's
just wanna
stalk
see.
Miles. So let's stalk Miles.
Hmm.
Miles, do you want to get stalked? I sent you a transaction today. Must I like share the
You did.
details? No, I won't do that. It's all good. It was on Stellar. I just like okay, wait. I'll let you run with it and I'll see if I can get that stuff. Do you mind, Miles? You can say no, it is your
Not at all.
privacy. Okay, cool. I'll share it
That's
now.
all good.
Cool.
Okay, so
Okay,
it's
so here we are.
is this the transaction I'm looking at?
So this is a ledger,
Mm-hmm.
and we can see the sequence number, the close date. So I want to go to a specific transaction. Let's see. Come on. It's a little bit of lag. Yeah, so here in Stellar Expert, you can see transactions. Come on, hurry up.
So Ethan,
Okay.
I see.
It's in the chat, Ben.
Okay, so okay, thanks. So let's go for it. So this is an address that Mukhtar Mir just sent to me. So I'm going to search for it. Okay, so yeah, this is the account. We can see the balance 1.9 XLM and the dollars 61 USDC. Okay, and we can see the total payment. Like, let's go back to and here are the transactions. Sent $1 to this person, $1. So whoever this person is very generous. It's been sending $1. Is it your wallet, Mukhtar?
It's the wallet activation thing of activating the Beans wallets.
Yeah, so it's a lot of $1 that has been sent. You can see the time. So we're not gonna know exactly like we're not gonna know who sent it, but we just know the address and all the transactions that it has ever done.
Do all addresses start with GCY?
G. All the address start with G for on Stellar. Yeah.
Okay. Okay, cool.
And another thing I also want to show you is the tokens. You can also see different tokens on Stellar. Like XLM is the. Sorry, it's just some noise here. So XLM is the native token for Stellar. And you also find Bitcoin, you also find ZOR, Z. Now, some of you know Zim, Zozi. You can see BTC. So all these companies. Let's go to Zozi. So Zozi is a stable coin, a Rand stable coin, one-to-one with friend. You can in here you can see who issued it. It's Zim Money. You see the address. You see the total supply, 4.7 million Rand. You see the total payment count. So there's yes, Mouse.
Oh no, carry on. I'm gonna ask my question when you're done.
You see the total payment count. You see the volume and all that. So anybody can have their own token. So you can also create one.
Is there a way to view contract code on this Explorer? Like, can you verify your smart contracts?
You're not going to see the full code. Let's look at the smart contract. Stellar Lab. Stellar Lab.
So, like, do you know even if there's any
Just
functionality like
you
Etherscan
see
has, where you
function.
can
You're
like,
not going to see the full code though. You're not going to see the full
okay,
code. So let me show you. So Stellar Lab is another important website for devs. Here you're going to see smart contracts, Contract Explorer. Oh, my internet is slow. Let me turn off my video. Maybe.
and then contract addresses start with a C. I'm assuming.
No. Yeah. Yes.
Cool.
Okay. Yeah, I'm connecting. I'm not show you tomorrow how to do this.
I think G is for gullible and C is for contract.
So here a list of contracts. We can load it and can look at the source code. So here you see the functions. But here you're not going to see the source code. So
Yeah, seems you have to verify it first. Okay, cool. That's awesome. It's nice to know you can do that.
contract storage, version history. So yeah, but we're gonna do that. We're gonna go through into this later, the later stage. Yeah, anybody has a question about the Explorer? Any question before we conclude? Yes, Ethan?
What's a limit on how much code you can put? Is it one block or is it multiple blocks that represents the code? Because from what I understand, a single block in a blockchain is limited to how much data it can hold. So if you're going to put megabytes of code into a smart contract, would you not be limited?
Yes, there's a limit. There's a limit. It's in
And this is all Rust.
Yeah.
Okay. Thank you.
Okay, so that was how blockchain works. And so far, did anybody go through consensus? The second slide. Okay, 2 people. Okay. Yeah. 3 people. Nice.
Not in this course,
Sorry?
but in a different one.
Okay, nice. So tomorrow we're going to cover wallet, how they work, how private key work, public key, and as well as we also going to create. I'm also going to create a wallet with you guys and do a few transactions, and I'm also going to take questions from you regarding the slides. Yeah. So thank you. Anybody? Joel?
Good evening, everyone. I was a bit late, so I didn't catch like the first part of today's session. So I just wanted to know, like, where can I access the recording so that I can watch it in my own time?
It's in our YouTube channel. I don't know if you have it. The YouTube channel.
Yes, I do. So so yesterday's session and today's session is on there, right?
Mukhtar, is it there already?
Yeah, I need to add today's session, but I'll do it tonight after the call, because yesterday it uploaded pretty down. I don't know, it figured itself out pretty quickly and allowed me to access the video. So I'll do that.
Okay, cool. Thank you so much.
Thank you, Mukhtar. Yeah, that's it for the evening. Thank you guys for joining. I really appreciate you. And tomorrow, same time, same place.
Cool. Thanks, Ben.
Cool.
Good
Thanks,
night.
guys. Enjoy your night. Thanks, Ben.
Good night.
Cheers, guys.
All right.
Cheers.